So in this video we're going to do an equation in quadratic form again, but this time we're going to work with rational exponents. So we have the equation x plus 1 to the 2/3 power minus x plus 1 to the 1/3 power minus 2 equals 0. And then I want to recognize that this can be rewritten as x plus 1 to the 1/3 squared, because 2 times a third is still 2/3, minus x plus 1 to the 1/3 minus 2 equals 0. And then I can make the substitution. I can say let u equal x plus 1 to the 1/3, and then if I go through and make that substitution here, I'm going to get u squared minus u minus 2 equals 0, and now I have an equation that looks like a quadratic equation. So the original equation was in quadratic form. Now I can use any quadratic equation technique that I know to try to solve this. I can use the quadratic formula, complete the square, try factoring. In this case it factors pretty nicely because we get u minus 2 times u plus 1. If we multiply this out, we'll get u squared minus u minus 2. So our check on work, if we needed to, would be to multiply this out and make sure we get the previous expression back. Now I have a product of two factors, so I use the zero product property to say either u minus 2 equals 0 or u plus 1 equals 0. So this means that either u is equal to 2 or u is equal to -1, but I want to remember that u represents an algebraic expression, so I need to substitute back. So for this one, I get u equals 2, but u is really x plus 1 to the 1/3, so that needs to equal 2. And then I look at the numerator of this rational exponent. I see that it's not even. If it were even, I would need to get a plus or minus in my solution process, but it's an odd numerator. So I'm just going to take both sides of this equation and raise each side to the 3rd power. And I'm going to do that because 3 times a third is 1, so I get x plus 1 to the 1st power, which is just x plus 1. I get 2 cubed, raise each side to the 3rd power. 2 cubed is 8. And then subtract 1 from both sides, we get x equals 7. So this is a solution candidate, and we probably should plug it back into the original and check that it works. Let's get the other equation first. Here's one solution candidate. The other one, we get u equals -1, so u is x plus 1 to the 1/3. From our substitution, it needs to equal a -1. Because the numerator of the rational exponent isn't even, it's okay to have a negative output over here. So I'm going to raise each side to the 3rd power. And 3 times a third is 1. X plus 1 to the 1st power is just x plus 1. -1 to the 3rd power is -1, and then subtract 1 from both sides. We get x equals -2. So here's our other solution candidate. And then you'd need to plug those in to the original and make sure that they work. So for example, if we plug 7 in here, we would get 7 plus 1 is 8. And then the 3rd root of 8 is 2, and 2 squared is a 4, minus. And we plug 7 in here, we get 7 plus 1 is 8. The 3rd root of 8 is 2, so we'd get 4 minus 2 minus 2. And does that equal 0? It does. 4 minus 2 is 2, minus 2 is 0. 0 equals 0, so when we plug in 7, we get an identity and it works. And then we could plug in the -2 also. If we plug -2 in here, we get -2 plus 1 is -1. The 3rd root of -1 is -1, because -1 times -1 times -1 is -1, and then -1 squared is +1, minus, plug -1 in here, plug -2 in here for x. We get -2 plus 1 is -1. The 3rd root of -1 is -1, minus 2, and that needs to equal 0. So we get 1, we get a double negation. 1 plus 1 is 2. 2 minus 2 is 0. You get 0 equals 0. So both numbers check if you plug them into the original equation, and you really do need to do that, unfortunately.